Hello and welcome back to Forbest Academy, and welcome back to our AMC 1012 past paper breakdown videos. This week we are looking at some past paper questions from the AMC 12, and we are breaking down the concepts required to answer those questions. And today's question: in the equation below, A and B are consecutive positive integers, and A, B, and A plus B represent number bases. 132a plus 43b equals 69a plus b. So in this question, we're talking about number bases. I'll quickly show you an example before we start the question. The idea is that we can represent numbers in different bases. So for instance, the numbers we use in maths usually, if I take 631, this is base 10. So it means this 6 represents 6 times 10 to the power of 2. This 3 represents 3 times 10 to the power of 1. And the 1 represents 1 times 10 to the power of 0. In the same way, if I had, say, 231 in base 5, the 2 would represent 2 times 5 to the power of 2. The 3 would represent 3 times 5 to the power of 1. And the 1 would represent 1 times 5 to the power of 0. So that is how number bases work. So if you have a look at this question here, we're given 132 to the base A. So that's going to be 1 times A to the power of 2 plus 3 times a to the power of 1 plus 2 times a to the power of 0. And then we have 43b, so that would be 4 times b to the power of 1 plus 3 times b to the power of 0. So if we simplify that down a little bit, we've got a squared plus 3a plus 4b plus 5. And we've been told that is equal to 69 to the base of a plus b. So that would be 6 times a plus b to the power of 1 plus 9 times a plus b to the power of 0. And again, if we simplify that down, we've got 6a plus 6b plus 9. We're told that these are equal to each other. So if we get rid of my working out here, and we can set these equal to each other and look at trying to solve this equation. So the other key piece of information we've been told in this question is that A and B are consecutive numbers. So therefore we can write down that B rather, B must be 1 larger than A if they're consecutive. B is equal to A plus 1. If we substitute those values for B into our equation, we're going to get A squared plus 3A plus 4 times A plus 1, so plus 4A plus 4. Plus 5 equals 6a plus 6 times a plus 1, so that's 6a plus 6 plus 9. We have everything in terms of a now, so let's form ourselves a quadratic that's equal to 0. And that will be a squared minus 5a minus 6 is equal to 0. If we factorize this, we'll get a minus 6 and a plus 1. is equal to 0. For this to equal 0, either a minus 6 must equal 0, in which case a equals 6, or a minus 1 must equal 0. So a plus 1 must equal 0, in which case a will equal -1. Now, they've told us that a and b are positive integers, so that value of -1 can be ignored. It cannot equal -1, so a must equal 6. If a equals 6, we know that b is 1 larger, so b must equal 7. So what is the value of a plus b? 6 plus 7 is 13. Thank you very much for watching our video today. Please like and subscribe our channel below. And don't forget to tune in for the rest of this week for more breakdown of AMC 12 past paper questions. Thanks very much for watching. I look forward to seeing you again tomorrow.